Today I will discuss the new topic on Zero-One matrix called Boolean products on Zero-One matrix. All the diagonal values should be 1. Then it is reflexive relation. In Boolean operation we have two rules, addition and multiplication. So here we can represent reflexive relations in a Zero-One matrix. Hello everyone, welcome back to my new session. I am Shweta, Computer Science Faculty, Vidhyaashram First Grade College, MYSURU. In my last session, I have discussed about Zero-One matrix. Today I will discuss the new topic on Zero-One matrix called Boolean products on Zero-One matrix. So what is the meaning of this Zero-One matrix? Computer can recognize only zeros and ones, right? So we can represent this 0, 1 in matrix form. So in 0 and 1 matrix, usually we'll get all the matrix values in zeros and ones. If you get the matrix values are 0 and 1, we can call it as it is a 0-1 matrix. And in my last session, I have discussed about join and meet. So in join and meet, all the B1 is equal to B2 value is equal to 1. And in meet, B1 is equal to 1 and B2 is equal to 1. I have explained with an example. So today I will discuss the Boolean products on 0-1 matrix. So what is this Boolean products? In Boolean operation, we have two rules, addition and multiplication. Boolean addition and multiplication. And operation is called as multiplication or operation is called as addition. So here we are applying only product. Product in the sense we are using only AND operation. So how to simplify this Boolean products on 0-1 matrix? Let A is equal to A of ij. I means row, j means number of columns. Ij be an m into k 0-1 matrix and Bij be k into n 0-1 matrix. Example, if your matrix is 3 cross 2 matrix and 2 cross 3 matrix, so here you will get the final answer with 3 cross 3 matrix. So m into k and k into n. The Boolean product of A and B denoted by A Boolean operator B. A Boolean operator B. The symbol is called as Boolean operator. Is the m into n 0-1 matrix with ij. So if your m cross k and k cross n, so finally you will get m cross n with 0-1 matrix. So if you get 3 cross 2 matrix and 2 cross 3 matrix, so final answer will be 3 cross 3 matrix. So m into k and k into n, you will get m cross n. And how to simplify this m cross n? So here you have to use this method. Cij is equal to ai1 and this is and symbol ai1 and bj1 or operator. This symbol is or ai2 and b2j and again or up to aik and bkj. This is one representation of Boolean products of 0-1 matrix. So let us understand with an example problem. So find the Boolean product of A and B. We have two matrices, matrix A and matrix B. So you just observe the matrix values 1 0 0 1 1 0. It is 3 cross 2 matrix, 3 rows and 2 columns. And matrix B is 1 1 0 0 1 1. It is 2 cross 3 matrix. So final answer will be 3 cross 3 matrix. So you will get 3 cross 3 matrix, right? So here how to find 3 cross 3 matrix using Boolean product. So first step is A Boolean operator B. So how to find the matrix here? Multiply this first row with all the columns. First row is 1, 0. With all the columns you have to multiply. And second row with all the columns. Third row with all the columns. That's it. So 1 into 1 and 0 into 0. So 1 and 1 or 0 and 0. So you will get 3 cross 3 matrix. So here first row with first column, again first row with second column, again first row with third column. Again first row 1 and 1 and 0 and 1. And the third column 1 and 0 or 0 and 1. Next, second row is 0, 1 with all the columns. 0 and 1 or 1 and 0. 1 and 0. Second row with second column. 0 and 1 or 1 and 1. And the third column 0 and 0 or 1 and 1. And third row with all the columns 1 and 1 or 0 and 0. Next 1 and 1 or 0 and 1. And 1 and 0, 0 and 1. 1 and 0 or 0 and 1. So first write this properly. So easily you can find the Boolean products. Here I have OR operator. So first find 1 and 1, 0 and 0. 1 and 1, 0 and 1. 1 and 0, 0 and 1. It is multiplication operator. So multiplication means 0, 0 is 0, 0, 1, 0, 1, 0, 0, 1, 1 is 1. So for addition, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 1. So find these values properly. 1 into 1 is 1 or 0 into 0 is 0. Again 1 into 1 is 1, 0 into 1 is 0, 1 into 0, 0 and again 0 into 1, 0. And the next value 0 into 1, 0 or 1 into 0 is 0. And again 0 or 1. Third value is 0 and 1. And again fourth value 1 into 1 is 1 or 0 into 0, 0. 1 into 1, 1. 0 into 1, 0. 1 into 0, 0 and 0 into 1 is 0. So here you have to write the OR operator and now you can find the final value. So 1 or 0. 1 or 0 in the sense 1 plus 0 is 1. 1 plus 0, 1. 0 plus 0, 0. 0 plus 0, 0. 0 plus 1, 0 plus 1. 1 plus 0, 1, 1 plus 0, 0 plus 0. So this is your Boolean product. The Boolean product of A and B. You just multiply all the row values with all the column values. So first row value is 1 and 0. Multiply with all the columns. 1, 0 with 1, 0, 1, 1, 0, 1. So first line. And the second row is 0, 1. Multiply this 0, 1 with all the column values. 0, 1 with 1, 0, 1, 1, 0, 1. And the third row is 1, 0. Multiply this 1, 0 with all the column. 1, 0 with 1, 0, 1, 1, 0, 1. So you will get the final value in 0 and 1s. This is your Boolean product of 1 and 0. It is very simple concept. Already you have studied this in school days, right? So easily you can simplify this Boolean product. And the next problem is find the Boolean product of A and B. Here you have two matrices. It is 3 cross 3 matrix. This is 3 cross 2 matrix. So 3 cross 3 and 3 cross 2. So you will get 3 cross 2. So this is m value and this is n value. M into k and k into n. So you will get m cross n. Here in this problem you will get 3 cross 2 matrix. 3 cross 2 matrix. It should be in 3 cross 2 matrix. So m value is 3. That means rows are 3 and columns will be 2. So before I have explained the Boolean products, right? All the row values should be multiplied with column values. And all the row values should be multiplied with column value. All the row values should be multiplied with column values. You will get the Boolean product. Please practice this problem. And the next method is representing relations using 0-1 matrices. So in 0-1 matrices, we can represent the relations also. So what is relation? Relationship between the elements of sets are represented by using the structure called as relation. This 0-1 matrix we can represent it in relation also. So here let R be a relation from A of A1, A2, A3 up to AM to B1, B2, B3, Bn. So here we have two sets elements. So set A and set B. The relationship between the sets are represented by using a one structure called as relation. And the relation R can be represented by the matrix called MR. Matrix representation is equal to Mij. Number of rows and columns. MR is equal to Mij. Example, Mij is equal to 1 if A of I, B of j belongs to R and 0 if A of I, B of j should belongs to R. All the number of rows and number of columns should belongs to R. Already I have discussed about the properties of relations, right? So we have different properties on relations. We have studied reflexive property, symmetric property, transitive property, asymmetric property, etc. So this 0-1 matrix can represent using relations. Relations property also we can represent in this 0-1 matrix. So representing relations using 0-1 matrix. So here we can represent reflexive relations in a 0-1 matrix. So how to represent this reflexive relation? What is reflexive relation? If A comma A belongs to R, B comma B belongs to R, C comma C belongs to R, etc. Let R be a binary relation on a set and let M be its 0-1 matrix. So let R be a binary relation and M be its 0-1 matrix. R is reflexive if and only if Mij is equal to 1. That means all the rows and column is 1. Row value and column is 1. We can call it as it is reflexive because reflexive means AA, BB, CC belongs to R. Reflexive means both the values are same. AA belongs to R, BB belongs to R. In 0-1 matrix, we can represent this all elements are equal to 1 on the main diagonal. Then we can call it as it is reflexive relation. All the diagonal values are 1, then it is reflexive. Example here I have 0, 0 and 0, 0, 0. All the diagonal values should be 1. Then it is reflexive relation. Example, I have set elements A, B, C, D. In column also I have A, B, C, D. You just observe this. In place of AA, I have 1. So relation R is equal to AA is 1. And in place of BB also I have 1. And CC also I have 1. And DD also I have 1. So it is satisfying the reflexive relation. AA belongs to R. It is reflexive. This condition is satisfying the reflexive relation. In 0-1 matrix also we can represent relations property. And the next property is symmetric property. So what is the meaning of this symmetric? Symmetric property means if AB belongs to R, then BA belongs to R. If AB belongs to R, BA also belongs to R. So symmetric property in 0-1 matrix. Let R be a binary relation on a set and M be its 0-1 matrix. R is symmetric if and only if M is equal to MT. In other words, Mij is equal to Mji. If A belongs to B, B is also belongs to A for all I and j. So here I have 0, 0, 0, 0, 0, 0, 0. I have 4 set elements A, B, C, D, A, B, C, D. I have 4 set elements. So here Mij is equal to Mji. I will find whether it is symmetric or not. So AB relation R is equal to AB, and in place of BA I have 1 BA, and CD, and in place of DC also I have 1. Is this symmetric? Yes, it's satisfying symmetric property. It's satisfying symmetric property because AB belongs to R and BA is also belongs to R. It is symmetric property. So this is about your symmetric in a 0-1 matrix. And the last topic is anti-symmetric property. Anti-symmetric in 0-1 matrix. So what is this anti-symmetric? Let R be a binary relation on a set and M is a 0-1 matrix. Again, Mij is equal to 0, Mji is equal to 0 if I is not equal to j. Example, here I have 4 set elements A, B, C, D and A, B, C, D. So it is 0, 0, 0. It is also 0, 0, 0, 0 and 0. Now, relation R is, in place of AB, I have 1, A and B. And in place of DC, I have 1. So, remainings are 0. AB is 1 and DC is 1. Example, 1 is equal to 2. So, 1 is not equal to 2. And so, 3 is not equal to 4. It is called as anti-symmetric property. It is opposite of symmetric property. So, this is about your relations in 0-1 matrix. So, we have studied so many properties on relations that we can apply in 0-1 matrix also. So, this is about your 0-1 matrix and Boolean products on 0-1 matrix. Dear students, already have completed so many topics in Unit 1. Still, you have one more unit called as diagram. In my next session, I have discussed the partial orders and as diagram. So, please practice all the problems on first units. I have discussed sets and operations on sets, operations on sets, and loss of sets, and Venn diagram. Venn diagram is very important concept. Venn diagram also I have explained, and also I have discussed about functions, one-to-one, many-to-one. One-to-one I have discussed, many-to-one, one-to, on-to functions, into functions. Everything I have discussed in function sessions, and also I have discussed relations. And in relations I have discussed all the properties of relations, and I have discussed 0-1 matrix. In 0-1 matrix I have discussed join and meet, and Boolean products, and last topic, pending topic is partial orders. Partial order and has diagram is pending, has diagram, and partial order is pending. My dear students, I am completing all the topics, but you have to practice more. Please practice all the problems on discrete transformation. Easily you can score centum in discrete transformation. It is very easiest subject in your syllabus. Easily you can score 100 out of 100 in discrete transformation. So in my next session, I will discuss the partial orders, introduction and Hash diagram. So today you learned the Boolean products on 0-1 matrix and you have studied relations on 0-1 matrix. Relations property is called reflexive property, symmetric property and anti-symmetric properties on 0-1 matrix. In my next session, I will discuss partial orders. Thank you.